Hey everybody, this is 7.1. So now we're moving into chapter 7. I know that you are going to be really excited that chapter 7 is a return to factoring. Try to contain yourself, I know. So in this section, we are going to do the square root property and completing the square. These are two different tools. We're going to talk about when to use each one. So the square root property is a super helpful tool. Basically what it says is that when you have a number x squared equals k, you can solve it by, oh, I don't have my marker, I did, by taking the square root of both sides. So if I have x squared equals k, take the square root of both sides, x equals plus k, or plus or minus the square root of k. You can write it like this, you can write them separately. This is going to be, plus or minus together is going to be sort of our shorthand here. So we can use the square root property to solve equations like this. When you are using the square root property, what you're going to look for is the ability to get x squared or whatever variable squared on one side and numbers on the other. When you use the square root property, this is what you're looking for. Sometimes it's going to be something in parentheses squared equals a number. But this is sort of what you have your eye out for. So this problem we can take and we could divide both sides by 4. And I get p squared equals 9 over 4. Well, now I have this perfect situation. I have the squared on one side and just numbers on the other. So I'm going to take the square root of both sides. I don't want to take the thing is I don't want to take the square root of a whole bunch of stuff on the left. That's just miserable. So I want to just get my variable. And then the square root of 9 over 4 is the same as plus or minus 3 over 2. And we're done. All right, this one works the same way. 25a squared equals 16. I'm going to divide both sides by 25. I'm going to get a squared equals 16 over 25. I'm going to take the square root of both sides, and I get a equals plus or minus 4 over 5. The plus or minus has to be there. It's not optional. Okay, once we take the square root, what comes out is plus or minus. So let's see if we can apply it here. Well, I want to get, remember what the goal is, x squared on one side, everything else on the other. So I'm going to start by moving my 75 to the other side. So I get 3x squared equals negative 75. Okay, divide by 3. I get x squared equals negative 25. All right, take square root of both sides. Remember that we now have imaginary numbers. So on the left, I get x. On the other side, the square root of negative 25 is really, let's see, the square root of negative 1. And the square root of 25. Square root of negative 1 is I. Square root of 25 is 5. So the answer here is x equals plus or minus the 5i. All right, try this one. You try this one, please. Your final answer should be plus or minus 3i. Okay. This is another instance of the same exact thing. Do not let the parentheses throw you off. Basically what's happening is I have something squared equals a number. This is the same idea. I have x squared. Doesn't matter what that x is. It can be something in parentheses on one side and a number on the other. So this I'm going to solve the square root property. Take square root of both sides. On the left, I get w plus 3. Squared and square root cancel each other out. On the right, I get plus or minus the square root of 20. Well, that I have to break apart, right? So I'm going to break that into square root of 4, square root of 5. So 2 square roots of 5. So plus or minus, oh my, plus or minus 2 square roots of 5. W plus 3 on the left, minus 3. And here's the thing, the 2 square roots of 5 is not the same kind of term as the minus 3, so I'm just going to write minus 3 plus or minus 2 square roots of 5. I'm done. Okay, generally speaking, this plus or minus whatever happens back here is going to go second. Doesn't really matter though, whatever order works. Try this one. Works exactly the same way. You're going to take the square root of both sides. Okay, so over here on the left, I'm going to get t minus 5. On the right, I'm going to get plus or minus the square root of 18. Well, that's 2 and 9, right? So 3 square roots of 2. T minus 5 equals plus or minus 3 square roots of 2 plus 5 to both sides. So I get t equals 5 plus or minus 3 square roots of 2. Leave it like that. You do not have to feel compelled to make them into decimals. It is not important. This, being able to get to here, is important. All right. So now that's a square root property. Let's move towards completing the square. Completing the square is a really important skill. It's going to feel like a really complicated thing to you for a minute, but we're going to use it here, and then we also use it later in the semester again. It's really important to get. So the idea is we can change this binomial somehow to add something to it to make it a perfect square. We have to determine the value of n that actually makes that happen, and there's a way to do that. What we do is we take whatever the b value is. So here it's 12. We multiply it by half, or divide it by 2, same difference. And then we square that whole thing. Okay, so half of 12 is 6, right? 6 squared is 36. So that is the value that I'm going to put in here for n. So x squared plus 12x plus 36. And now think about it. If I factor this, it's going to be x plus 6, x plus 6. That is a perfect square. Okay? This is my goal. I want to make a perfect square trinomial. So let's try it again. I have x squared minus 26 plus that, whatever I'm going to add there. So do the same thing. You take the b value, you multiply it by half. So half of negative 26, then I'm going to square it. So half of negative 26 is negative 13. Negative 13 squared is 169. So my perfect square trinomial here is x squared minus 26x plus 169. Done. That would be my number. Do it again. What are you going to get? So we're going to do x squared, let's see, half. My b value is 11. Half of 11 squared. Okay, half of 11, well, boo. I'm just going to leave that as 11 over 2. Honestly, you don't have to divide that. Just live with it. It's not going to hurt you. 11 over 2 squared is 121 over 4. If you want to simplify that, great. Honestly, I'm not gonna. That's what I would put in for n. I don't need to do anything scarier than that. Let's try this one. Same thing. Figure out the n value. It's half times negative 4 over 7. That whole thing squared. So half times negative 4 over 7, 1 times is negative 4 over 14. I'm going to simplify 4 over 14 just to make my life a little easier into 2 over 7, because I would rather square 7 than 14. So negative 2/7 squared would be 4 over 49. It's done. That's it. Okay? That's the value I'm trying to figure out. All right. For each of these, you should go figure out the value of n. Really do try it. This is an important step here. For number 4, the value is 100. When you figure it out, for number 5, to check your work, the value is 64. For number 6, the value is 15 over, let's see, 225 over 2. And for number 7, it's, 225 over 4. The value is 49 over 36. Okay. In each of these cases, going back, if we go back one step, let's go back a couple. If I were to write out the perfect square, the binomials as a result of this, in the first case, it would be x minus 13, x minus 13. Do you see that number with negative 13 there? It's the number you have before you square it. Here, in the next one, my perfect square binomials would be made out of x plus 11 over 2 and x plus 11 over 2. The thing there before you square it. Here in this next one, it would be made out of x minus 4 over 14, x minus 4 over 14, okay? That is where this number to make the binomials comes each time. It's the step after you multiply by half, before you square, okay? So to solve something with completing the square and square root property, because the goal of this is to be able to solve equations. The first thing we need to do is to remember that we need the leading coefficient of a, okay, to be 1. So whatever the squared term is here. If you miss this step, you break this whole thing. So if there is a number in front of the x squared, you have to divide it away. And we'll show you examples. But you cannot miss that step. It's a really important step. It deserves a star. Once you get there, put the variable stuff on one side. So ax squared plus bx on one side, all the numbers on the other side. And then complete the square. Then once we do that, we'll have a perfect square and we can use the square root property. Sounds crazy, we're gonna do it. So the first thing is, I'm gonna look at this and go like, there's no real way to factor this. And there's no real way to just get x squared on one side and no x's on the other, so I have to do something else. Fine, I'm gonna complete the square. So there's no number in front of x squared, I don't have to worry about that step. I'm gonna move the 13 to the right. X squared minus 6x equals negative 13. Now I'm gonna pause for a second and I'm gonna figure out what that trinomial would be, what that n would be. So it would be negative 6 divided by, or times a half, squared. So negative 6 times a half is negative 3. Negative 3 squared is 9. So my n would be 9. What I'm going to do with that is add it to both sides, not just one side. So on the right, I'm going to, or sorry, left, x squared minus 6x plus 9 equals 9 plus negative 13 is negative 4. Okay? Make sure you're with me so far. You're with me so far? And then I'm going to write my binomials. This x squared minus 6x plus 9 factors into x minus 3, x minus 3. I can write that as x minus 3 squared. Okay? And I'm gonna. So I'm going to rewrite that as x minus 3 squared equals negative 4. And lo and behold, now I can use the square root property. So on the left, I get x minus 3. Ooh, I ran out of room. Hold on. I'll do that in green right here. X minus, get your marker. X minus 3 on the left equals square root of negative 4 would get me 2i, plus or minus. Add 3 to both sides. So x is 3 plus or minus 2i. And it's done. We completed the square and used the square root property. Ta-da! Try again. Okay? Same exact steps. Move the 26. There's no, pardon me, coefficient in front of the z squared. I don't have to worry about that. So I get z squared minus 4z equals negative 26. Now I'll go off to the side. Z squared minus 4z plus something. What's that something going to be? Well, half times negative 4 squared. Half times negative 4 is negative 2. Negative 2 squared is 4. So I'm going to add 4 to both sides. Plus 4, want the red, plus 4. So I get z squared minus 4z plus 4 equals negative 22. True? Okay. Now I'm going to write the left-hand side as whatever this. I'm going to write it as that binomial. X minus 2 squared equals negative 22. Now I can take the square root of both sides. X minus 2 on the left equals square root of negative 22. Well, it's just kind of I plus or minus I radical 22. Okay. I'm going to add 2 to both sides. So I get x equals 2 plus or minus I roots of 22. That's all. Okay. Process same time and time again. The more you do it, the better you will be. All right. This is an example where there's a coefficient in front of m squared. We have to deal with that first. So what we are going to do is just divide through by it. Divide by 2, divide by 2, divide by 2. You have to divide every term by 2. So I get m squared plus 5m equals 3 halves. Don't let the 3 halves freak you out. It's okay. But now you see I'm in a position to complete the square, so I'm going to go off to the side. I'm going to say m squared plus 5m plus something. So half times 5 squared gets me 5 over 2 squared, which gets me 25 over 4. That's what I'm adding to both sides. Plus 25 over 4. So on the left, I'm going to make that perfect square, and then I'm going to make it a binomial. M plus 5 over 2 squared. On the right, well, 3 halves is the same as 6 fourths. So 6 and 25 is 31 over 4. Right? Okay, now I have the ability to complete the square, or use the square root property. So on the left, I get m plus 5 over 2. On the right, I just get, well, let's see, square root of 31 over square root of 4 gets me square root of 31 over 2. So I get plus or minus square root of 31 over 2. All right, now I'm going to take away 5 halves from both sides. So I get m equals, these guys have the same denominator. I can just combine the numerators. Plus or minus, sorry, not plus or minus. Negative 5 plus or minus square root of 31 all over 2. That's all it is. Okay? I want you to try this one. Everything gets divided through by 4. I think that you can do it. Works just like the last one. The answer to this one should be x equals negative 3 plus or minus the square root of 14 also over 2. Okay? Let's try another. This one looks insane, right? But here's the thing. We don't deal with anything that isn't in standard form first. So put it in standard form, okay? So multiply through, break up the parentheses, combine things. So I get 4x squared minus 20x equals negative 30 plus 6x. Well, I'm going to move the 6x to the other side. All right, so I get 4x squared minus 26x equals negative 30. All right, now I'm in position to complete the square, right? So the first step, divide through by the 4. Okay, I'm going to move my thing down a little bit. X squared minus, let's see, I can simplify that at least, 13 over 2x equals, I can simplify that to negative 15 over 2. All right, these fractions are not going to kill you. It's okay. So now off on the side, let's complete our square. All right, so negative 13 over 2 times half That whole thing squared gets me negative 13 over 4. Squared gets me 169 over 16. Okay, that's what I'm adding to both sides. It's not pretty, but I don't really have to deal with it that much. Okay, so I get, and I'm going to erase a little bit to make myself some space, sorry. So I get, on this side, I get x minus 13 over 4 squared equals, well, 15 halves. I can make 16, so I can make 15 over 2 into 16ths when I multiply by 8. 15 times 8 is 120, right? 15 times 4 is 60 times 8 is 120. So minus 120 over 16 plus 169. So 169 minus 120 is 49. So over this, I'm going to get 49 over 4. Oh, this is going to work out better than I expected. So on the left, I get x minus 13 over 4. On the right, I get 7 over 2, plus or minus. Okay, now I just have to add. So I get x equals 13 over 4, plus or minus 7 over 2. In a perfect world, you should finish this, okay? So 13 over 4 plus 7 over 2, okay? I'm going to convert 7 over 2 to fourths. 7 over 2 is the same as 14 over 4. 13 over 4 plus 14 over 4 would get me 17 over 4. Or 13 over 4 minus 14 over 4 would get me 1 negative a fourth. Oh no. I feel like I'm in the wrong. Oh, I know what my problem is. I found it. This should have been 16ths, right? Because when I combined all that together, I made 16ths. So that's a 4. Sorry. My fault. I got 7 over 2 instead of 7 over 4. Okay, let me fix that. 13 over 4 plus or minus 7 over 4. No, that's easier than we think. Plus 7 over 4 gets me 20 over 4, which is the same as 5. Minus 7 over 4 would get me 6 over 4. And that's the same as 3 over 2. Yeesh, sorry, I knew there was something not right. Here's the thing. You'll get stopped sometimes, even like I do. Everybody makes mistakes. What you have to do is keep practicing. The more you practice, the better it gets, okay? All right, this one you should try. Standard form, same stuff, okay? When you get done, and you get all the way through this, there are 2 possible answers. One of them is 3 over 2. The other one is negative 1. See if you can figure it out. If you can't, drop in the discussion. Let's talk about it. All right, these are some of the applications of this. So it says ignoring air resistance, a distance d in meters that an object falls in t seconds is given by this equation. D equals 4.9 t squared. Solve for t. Don't rationalize the denominator. Basically what they want is you to move, you just want t by itself. Okay, I can do that. Divide both sides by 4.9. All right, I get d over 4.9 equals t squared. Take square root of both sides. I get plus or minus d square root of d over 4.9. Said don't rationalize the denominator, so I don't have to do anything. I can just be done there. Now it says the same formula. Using the equation you just made in part A, determine the amount of time required for an object to fall 500 meters to the ground. Well, so what we did is we solved so that we could get an amount of time, right? So now all we have to do is take our equation, which was plus or minus d divided by 4.9, square root of that whole thing equals t, and put in 500 where we see d. So 500 over 4.9, take the square root, equals time. I'm not going to give you the negative here, only because there's no negative time. You can figure this out in your calculator. 500 divided by 4.9, take the square root, we get about 10 seconds. All right? You can try this one. Solve for r is the first step, okay? And then to find the radius. When you find the radius, the answer is 2.24. See if you can make it work. All right, that's the end of this section. We're going to do 7.2 next. I will see you there.